This is a video walkthrough of a Gateway 1 exam. The solutions to this are written on here already, and I'll walk you through them. And so to start off, we have with number 1, express 0.5 divided by 1/2. So let's make them both fractions or both decimals. And you don't have a calculator to use, so let's make this guy a fraction. And 0.5 is 1/2, so we have 1/2 divided 1/2. When we divide a fraction by another, we're multiplying by the reciprocal of the second one. And when you do that, you can divide out these 2's to get 1 right away, or multiply across the numerator and denominator, 2 over 2, and that gets you 1. Remember, when you're doing this conversion, this question here is really asking you how many halves are there in 1/2. And so there is one of those in here, and that's why the answer is 1. With the negative exponents, that means they are unhappy where they are. For this guy, 3 to the negative 2 is really over 1. We then, because of that negative exponent, move the base of 3 down to the denominator and make the exponent positive. That gives you 1 over 3 squared. 3 squared is 9, so 1 over 9. For number 3, the absolute value, we do what is inside first. So 18 plus negative 29 is a difference of 11. The larger number is negative, so we keep that. So we have the absolute value of negative 11. Then we take the absolute value, and the absolute value is a positive number of 11. For number 4, we need to use our order of operations. We are going to do multiplication and division at the same time from left to right. So negative 2 times negative 3 is positive 6. 8 divided by 2 is 4. Notice the little braces, bring them down to show you what number comes from where. The negative 20 comes along for the ride. Now we're going to do addition and subtraction from left to right. Negative 20 plus 6 is negative 14. Bring the 4 down. Negative 14 plus 4 is negative 10. The answer is negative 10. For the next one, we have two fractions who have different denominators, so we need a common denominator. The least common denominator is 63. We need to convert that 7 in this denominator to 63, so we have to multiply by 9. We have to multiply the numerator by 9 as well. 6 times 9 is 54. 7 times 9 is 63. There's our LCD. For the second fraction, we need to make that denominator of 9 into a 63, so we multiply by 7 over 7, which is really 1, so we're not changing the number. 9 times 7 is 63. The numerator becomes 49. Then, because it is an addition or subtraction, we keep the denominator and we use the operation on the numerator. 54 minus 49 is 5, so we get 5 over 63. For the next one, number 6, hold on while I move this up. For number 6, what is an equivalent expression? We can add these two guys together. 9x is really 9x over 1, as you see here. We need a common denominator of 2, so we multiply this guy by 2 over 2. That gives us 9x times 2, which is 18x, over 1 times 2 is 2. Now, because we are adding, we keep the denominator as 2, and we add across the numerators. 18x plus x, which is 19x. So we have 18 of something, add 1 of something. That gives us 19 of that something, so that's 19x. Do we have that choice here? Yes, 19x over 2 is B, so the answer is B. For number 7, they're asking you to square this quantity. That's really saying, this exponent saying, multiply w plus 13 times itself 2 times. So we write it here, and then we use FOIL. W times w is w squared. 13 times w is 13w. Then outside, 13 times w, 13w. 13 times 13 is 169. Then we add like terms. We get w squared plus 26w plus 169. If you can't do 13 times 13 in your head, just write it over here. Get 169 and then put them in here. Okay. For number 8, first let's remember that when you're adding two fractions, what we did on the previous page, the denominators are the same, so we keep it and we add across the numerators. That gives us this 1 plus 1. We can go backwards when the denominator is a single value here it looks just like this. Instead of a 3, it's an x. So we can pull these two pieces of the numerator apart. So we get x over x plus 9 over x. If we went back up again, we'd say x plus 9 over same denominator, keep it x, and we get this guy. X over x, we divide those out to just get 1, so it's 1 plus 9x, which is C. A word of warning, there is an example within this exam where, not this particular one, but there are other samples where the denominator has the binomial in it and the numerator has just a single term. So say it's like x over x plus 9. We wouldn't be able to do anything with that because that numerator would not be able to be broken up like this can be. And that's how you can tell the difference of when you can split it and when you can't. The numerator has to have several pieces, then you can bring it apart. Let's look at number 9. This classroom used to have 20 seats. After the renovations, it now has 36 seats. By what percent will the number of seats have increased? So 20 times what percent is that 36? And so we can divide both sides by that 20. 36 divided by 20 is 1.8. Remember, do the longhand division over here, and you get 1.8 or 180%. Another way to do this, because percentage means out of 100, you could multiply the numerator and denominator by 5 here, and that would give you 180 over 100. That is then convertible to a percent, which would be 180%. So we get 180%. That means that we have 80% more than the 100% we had before. So you have 80%. Some folks do this as a proportion. You can do it that way if that makes sense to you. Number 10, we need to simplify. This is a negative sign in the middle, not a multiplication, so the x plus 3 comes along for the ride. Distribute that negative sign in, negative 2x. Negative times a negative is a positive. You get positive 4. So we have minus 2x plus 4. You can write them out here. I like writing like terms underneath of each other so that I can watch my signs. 8x minus 2x is 6x. Add these two numbers to get 7, and you get 6x plus 7. On the next one, you have to solve an equation, and you can see there's like terms on one side. So let's gather those like terms. 6y plus 5y is 11y. Negative 9 plus 8 is negative 1. The right-hand side comes along for the ride. Now we want to get all the variables on one side and the numbers on the other. The 11y is positive and already over here, and it's bigger, so let's take this 7y, subtract 7y from both sides. On the right side, that adds to 0, but over here, then, that gives you 4y. While we're doing that, let's move the constants to the other side, so negative 1 plus 1 is 0. Don't forget to add the 1 to this side as well. Negative 8 plus 1 is negative 7. We've got the variable term isolated. Now we need to divide by that constant, which is 4 here, the coefficient, and divide that by 4. They divide out on the left to give you y. On the right, you get negative 7 over 4. For number 12, solving this one, this is actually a simpler one than the last one. You've already got the step of isolating the variable done, so you just divide by that coefficient of 6. 54 divided by 6 is 9. For 13, we're evaluating this, so x equals 5, we put that 5 in for x. Y equals 9, we put that 9 in for y. Z equals 8, we put that 8 in for z. I recommend parentheses, as you see here. Just in case there were any negative signs, it's a good habit to have. 2 times 5 is 10. I keep the negative 5 minus 5. 3 times 8 is 24. 4 times 9 is 36. There's a plus sign in between there. Then simplify each of the numerator and denominator. 10 minus 5 is 5. 24 plus 36 is 60. This can be simplified because 5 divides 60 12 times. Go ahead and simplify that to get 1/12, which is the answer. If you don't like crossing out or slicing and dicing across the fraction, as you see here, you can factor out that common factor of 5, and then what you have left is 1/12. For number 14, this looks similar to one we had before, but these variables have higher exponents, so we're going to have to watch when we collect like terms. The first one comes along for the ride, negative 5w cubed plus w squared plus 13. This negative sign gets distributed to each term, so negative times the first one gives you a positive 7w squared. Negative times a positive 1 gives you a negative 1. Remember, my habit that I use is to write like terms under each other. This gives you then adding down negative 5w squared, 8w cubed, 8w squared, positive 12, and that is our final answer. Remember, you're trying to learn new habits of mind in this course, and so I recommend you start trying some of these procedures like this. This may actually help keep you from losing a term. In the next one, you have shares. They fell by 30%. If the original value is 80, what's the current value? Round to the nearest dollar. So we have the original amount minus the amount that's fallen. You get the current amount. Well, the original is 80. It fell 30%. So 80 times 0.3, we changed 30% to 0.3. 0.3 times 80, you can do your long arithmetic over here. You get 24. Subtract those two to get 56. Another way to do this, remember, is that instead of the amount fallen here and subtracting that, you could say that since it fell 30%, it's now 100 minus 30%, which is 70% of its original. So you could just take 0.7 times 80 and get the same exact answer. So either one works. If you have any questions, please feel free to come and see me. Hope you're having a great day.